Hello, everybody. Today we are doing lesson 2.4, which is the second part of solving polynomial equations. Now, this lesson is going to be a little bit more difficult with some of the problems because we are going to be using the quadratic formula. My cursor over here. So the quadratic formula here, I'm going to try highlighting. Let's see if I... So this is the quadratic formula. Ooh, there we go. All right, I can't figure out how to highlight. Oh, now we highlight. Okay, there's your quadratic formula. All right, and so that is our quadratic formula. Oh, I guess I have to go one way. You have used this before. The formula is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And you use this formula when you have a quadratic equation that has an x squared, an x term, and a constant, and you have to set your equation equal to 0. Just like if you were going to solve with factoring and you have to set it equal to 0, you have to set the equation, the quadratic equation, equal to 0 before you can plug it into the quadratic formula. And when you do plug it into the quadratic formula, you can get up to 2 real solutions, but you will always have a solution of some sort, but there's going to be imaginary solutions now also. So you'll have, there really will always be 2 solutions, kind of like we learned last lesson, but either they're going to be 2 imaginary solutions, 2 different real solutions, or 2 of the same solution, which we would call a multiplicity of 2. But the problems that we're going to be looking at today are mostly building you up to getting used to using the quadratic formula. Another concept that we're going to learn here today, or review here today, is the I, which is the imaginary number. So I is the imaginary number. And I does not equal square root of 1. I does not equal negative 1. I equals the square root of negative 1. So a lot of times I'll ask students, what is the value of I? And students will tell me negative 1. Well, that is not correct. It's the square root of negative 1. So now we have a couple problems over here where I'm just practicing simplifying radicals because that's where most students make mistakes when they are solving with the quadratic formula. So let's go to my pen here. Pick a color. All right, so I've got 2 different ones here. They're very similar. You've got a square root of negative 6 squared minus 4 times 3. And then over here, you've got the square root of negative 6 squared minus 4 times negative 3. And I get a lot of times where these are the students will make these the same answer. So you need to be very careful, especially after this minus sign. So if we were to square the negative 6, we get a positive 36. Regardless of whether it's positive or negative, when you square a number, it will always be positive. Over here, we basically get the same thing. However, when you multiply 3 times 4, you get 12, but then you're subtracting that value. So on the left side here, you've got 36 minus 12. On the right side, you've got negative 3 times negative 4, which will make that a positive 12. So this sign, the minus and the plus, be very careful when you are doing your problems. That is where most students make mistakes. All right, so going back to this one, if I subtract 36 minus 12, I get 24. Well, 24 is not a perfect square, but we have to simplify the radical, which means we are not going to change this to a decimal. We want to ask ourselves, first of all, are there any perfect squares that are factors of 24? So if you think of your factors of 24, you've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. So of these factors, the only ones that are perfect squares are 1 and 4. However, breaking this down into a square root of 1 and a square root of 24, where the square root of 1 becomes 1 and the square root of 24 is still in the radical, does not help us simplify the radical at all, which is why we do not want to use 1, even though it's a perfect square. So if I look at the other values, the only other one, that factor of 24, that's a perfect square is 4. So I want to factor the square root of 24 into the square root of 4 times the square root of 6, because 4 times 6 is 24 that you had in the first place. Now the square root of 24 becomes 4, and the square root of 6 cannot be simplified because, again, it does not have any factors that are perfect squares other than 1. So that now is factored completely. Going to the second one over here, instead of subtracting 12, if you add 12, you're going to get 48. So once again, if we list the factors of 48, 1 and 48, 2 and 24, 3 goes into it 16 times, 4 goes into it 12 times, 5 does not go into it, and 6 goes into it 8 times. So if I look at all these factors of 48, 1's a perfect square, 4 is a perfect square, 16 is a perfect square. So when you're simplifying radicals, you want to use the largest perfect square. So that is going to be this. I don't know if I can highlight. Nope, I can't highlight that. So let's use bright pink. Okay, so this 16 is the largest factor of 48 that is a perfect square. So you want to factor the square root of 48 then into the square root of 16, and always put the perfect square first, because when you put the perfect square first, then when you take the square root of it, it becomes a whole number and it goes right underneath it. But you're going to factor your square root of 48 into square root of 16 and the square root of 3. The square root of 16 then becomes 4, and you have this square root of 3 left over. So very different numbers here. And again, signs matter. Please pay attention to your signs. All right, so now that we've practiced simplifying a couple of radicals, we're going to work through this whole problem. I've got a few different problems here that are already in the quadratic formula. We just have to simplify them, because you're going to be doing this when you are solving quadratic equations with quadratic formula. So let me scroll down here. All right, so in example A, again, these numbers have already been plugged into the formula. We're just kind of simplifying this. In the numerator, you have, I'm going to go over here on the left side, x equals -6 plus or minus this radical. So this radical, I always like to simplify the radical like I did over here off to the side. So 6 squared is 36, 4 times 11 is 44, and I've got a minus in between. When I subtract 36 minus 44 now, I get -8. It's still under the square root sign. So now when I'm thinking about the square root of -8, I know that whenever you have a negative number under the radical, for right now, I'm going to factor out the -1, so I'm going to make the square root of -1 its own factor, and then move on to the 8. If you think of your factors of 8, you have 1 and 8 and 2 and 4. So 4 is the largest factor of 8 that is a perfect square. So the square root of -8, when you factor it into the square root of -1, the square root of 4, and the square root of 2 can now be simplified. The square root of -1 is I. So that's where we get that I from. The square root of 4 is 2, but the square root of 2 cannot be simplified any further. So I'm going to take this value now, this whole thing, and that is going to go in place of this radical. When you are putting these in, when you're writing this, all of this is like one term. There's a couple ways you can do it. You can put the 2, then the I, then the square root of 2, and that's probably the way a lot of you have been taught. Although technically the I should go at the end, but for right now we're going to leave it in front, and maybe the next example I'll put it at the end, but it doesn't matter to me where you put it. All right, now the last part of this problem is this dividing by 2. You must divide both the negative b, which in this case is -6, and the radical by 2. So this is like having 2 terms being divided by 2. So that 2 gets distributed to both parts of the number. Now take your -6 divided by 2, and you get -3. Now we really have 2 values here. We've got -3 plus, and if we reduce the 2's here, we would have I square root of 2. But we also have a second solution of -3 minus I square root of 2. So that's where we get our 2 different solutions. Although you can just write it as -3 plus or minus I square root of 2, but understanding that that represents 2 different values. And then as you get into higher level math classes, instead of having the I in front of the radical, the I typically goes in after the radical. And but make sure that the I is not under or not underneath that radical sign. It should not be part of the radicand. It should be outside of it. So this is another way of writing it. All right, hopefully that made sense. And if you have questions, please let me know. Moving on to the next problem. So this is similar, but we're going to have just a fraction, I believe. So, all right, so moving on again, once you fill in your formula, your quadratic formula, the 2 is brought down, my plus minus is brought down. I'm going to have this big fraction bar, but this radical is going to be simplified off to the side. So this -2 squared is a +4. The -4 times the -399 is actually a +1599. Or I'm sorry, not 99, 96. And when you add that together, you get 1600, which just so happens to be a perfect square. So you always want to ask yourself, when you simplify that radical and you get to this point, is this number a perfect square? If it is, then just take the square root of it and we would get 40. Now, some of you might not see that right away, or it might be a big number like this and you just don't know. So you could factor it into a square root of 16 and a square root of 100, where 16 times 100 does equal 1,600. The square root of 16, of course, is 4, and the square root of 100 is 10. So once again, you're going to get 40. So the 40 is not under the radical. We have already taken the square root of that number, and we get a whole number, 40. Your denominator now, actually, I'm going to erase this. The denominator is going to be 6 because you're taking 2 times 3. So if I divide both parts by 6 and then reduce, I would have 1/3 plus 40 thirds. Oops, wait, no, I want to reduce the 40 over 6. So both of them can be divided by 2. So when I reduce that, I get 20 over 3. But then you also have 1/3 minus 20 over 3. So when you add the 1/3 plus 20 thirds, you're going to get 21 thirds, which equals 7. So that is going to be one of your 2 solutions. When you subtract 1/3 minus 20 thirds, you're going to get -19 thirds. So that is going to be your other solution. So our 2 solutions are 7 and -19 thirds. Okay, so that's an example of one where you do end up getting a perfect square under the radical, and you can continue combining your like terms. Over here, though, you cannot combine a whole number or even a rational number with an imaginary number. You cannot combine a rational number with an irrational number like square root of 2. All you can do is write them next to each other. You can't even plug that in the calculator because it's undefined. That I is imaginary, which means this value is undefined. But we can write it as -3 plus minus I square root of 2. Over here, though, we did not have any imaginary or irrational numbers, which means we can keep going and add and subtract the 20/3 to the 1/3. All right, next example. Pink. All right, so again, over here, my x equals 4 plus or minus, and I'm going to take that square root part off to the side. And when I square the -4, I get 16. Now here I've got 3 numbers multiplied together, but when you're multiplying, you want to look at how many negative signs you have. The 4 is negative, the 2 is positive, the 7 is negative, so you've got basically 2 negatives, which is going to make this a positive number when you multiply it out. 4 times 2 is 8, times 7 is 56. And then you want to combine those, so 16 and 56 added together would be 72. And then you want to find a factor of 72 that is a perfect square. So if we think about our factors of 72, again, you've got 1 and 72, 2 and 36. I'm going to stop right there because 36 is a perfect square, and it's a pretty big number. So 36 and 2 are what I'm going to factor the square root of 72 into the square root of 36 and the square root of 2. The square root of 36 becomes 6, and you've got your square root of 2 left over. So take that and put that in the numerator, and that replaces this radical. Don't forget about your denominator, though. You've got 2 times 2, which is 4, and you have to divide both parts by that denominator of 4. So here we've got 4 over 4, which is 1, and then you're going to take 1 plus and 1 minus. Now reducing the 6 and the 4, I can reduce both of them by 2, which will give me 3 halves, but you still have the square root of 2, so I'm going to put 3 square root of 2 over 2. So the 6 becomes 3, the 4 becomes 2. My other solution then is 1 minus 3 square root of 2 over 2. But the 1 is not being divided by 2. We've already divided the 4 by 4, which gives us 1. So this is actually a number that we could put in the calculator, but make sure it's 1 plus 3 square root of 2 divided by 2, 1 minus 3 square root of 2 divided by 2. Those are your exact values. Now, some of you might have a calculator that reduces radicals for you, and in that case, it is going to give you an answer of, now let me write it over here. It's going to give you an answer of 2 plus or minus 3 square root of 2 all over 2. So you need to understand is that this answer here and these answers here mean the same thing. It doesn't really matter how you write it, as long as you understand that they are equivalent answers. All right, so that's a good practice of plugging and chugging and simplifying quadratic formula. Now we're going to start solving some of these quadratic equations. So all 5 of these problems here are quadratic, and I'm focusing on that because if you can solve quadratic equations, then you can solve some of these other polynomial equations that have higher degrees. So you don't have to use quadratic formula on all of these. The first three here, A, B, and C, we are actually going to use the square root method. So the square root method, that is not how you spell square root. So square root method, you only can use when you have an x squared and constants only. So if you look at these three examples here, they do not have a middle term. They have an x squared term and they have a constant with no x. They have an x squared term and a constant. You've got an x squared term and a constant. But these two examples, D and E, have an x squared and an x term along with a constant. So that's why we can use the square root method on examples A, B, and C, but we are not going to be able to use it on D and E. So with square root method, which is, I think, the easiest of all methods of solving quadratics, you have to isolate the x squared. So to get the x squared here by itself, we have to subtract 5. So you don't necessarily want your equation to equal 0. But as you see on the next set of problems, we're going to see when we're factoring, you get factors like this that you have to set equal to 0 and solve. So when there's no middle term, get your x squared by itself. Now when you square root both sides of the equation, you get x equals. Because it's an even root, there will be a positive and negative root. The square root of -5 can be broken down into the square root of -1 and the square root of 5. The square root of -1 is I, and the square root of 5 cannot be simplified because it does not have any factors that are perfect squares other than 1. So we're going to leave it as the square root of 5. And you can leave your answer like that, or in a lot of other textbooks, higher level textbooks, they're going to say square root of 5i with the I at the end. I will accept either answer. Okay, so these are hopefully seeming not too bad. So again, if we have something like this that's equal to 0 that does not have a middle term, you want to isolate the x squared. So to isolate the x squared, again, subtract the constant. The 4 that's in front needs to be divided. But this -25/4 cannot be reduced. You do not want to change it to a decimal. Just leave it a fraction. Now when we square root both sides, it does get a little bit complicated, but I'm going to break this down into the square root of -1 times the square root of 25 in the numerator over the square root of 4 in the denominator. Clean that up a little bit. So this is a square root of -1, a square root of 25, so that negative, I've made it its own little square root of -1. The 25 is in the numerator and the 4 is in the denominator. When you take the square root of -1, you're going to get I, but I'm going to leave this one at the end. The square root of 25 becomes 5. The square root of 4 is 2. And don't forget, because there is an even root, you have two solutions, the positive and the negative. So there is your solution for that. So if you have one that's a fraction like this, this is a good example to look at. Moving on to our third example, C. Again, we have a number, we do not have a middle term, so we want to isolate the x squared. So if I add 20 to both sides, I get x squared equals 20. Then take the square root. So because it's an even root, don't forget you're going to have a positive and a negative solution. And then again, think of your factors of 20. 1, 20, 2, 10, 4, 5. 1 is a perfect square, but that does not help us simplify radicals. So the only other factor that's a perfect square is 4. So we're going to factor the square root of 20 into the square root of 4 and the square root of 5. The square root of 4 then becomes 2. The square root of 5 cannot be simplified. So now we have our answer. Keep in mind, though, this does represent two solutions. X equals the positive 2 square root of 5 and x equals the negative 2 square root of 5. So those are actually two solutions even though we put that plus minus sign in front. Keep in mind there are two solutions represented there. All right, so those hopefully weren't too bad. Now let's move on to some that have a middle term. And we will be using our quadratic formula for these. So you might ask, well, how do I know I have to use quadratic formula? Why can't I just use factoring? Well, if we go through the methods of factoring, looking at this trinomial, I'm just going to do this over here. So we've got x squared minus 3x plus 9. If I tried to factor this, now please don't write this down because I'm going to be erasing it in a minute. If I try to factor this, my x squared would factor to x and x. But then if I think about my factors of 9, I've got 1 and 9, which would multiply together to equal 9. But do they add up to 3? No. So then I would ask myself, well, what are my other factors of 9? 3 and 3. Now, if I look at my signs, I have a plus sign here, which tells me my signs have to be the same and they both have to be negative. So if I look at this, the negative 3 times the negative 3 does multiply together to equal positive 9, but would they add up to negative 3? No. So that's not going to work. It is not factorable. So I'm going to erase all that because this is all stuff that I would go through in my head when I'm trying to figure out, do I have to use quadratic formula? So if you cannot factor and you have an x squared and an x term, then you need to use quadratic formula. All right, so once again, your quadratic formula, x equals negative b plus minus square root b squared minus 4ac all over 2 times a. Now there are a couple parts of this that I would recommend that you kind of do mentally. I'm going to kind of highlight them here. So this negative b, I would always recommend that you simplify that mentally. I also recommend that you square your b mentally. I also would recommend that you multiply your a and c together mentally, and then your 2a, you can do that step also in your head. So that whole thing is the formula. However, you're going to see that I'm going to simplify these 4 little pieces in my very first step. That saves you time and it saves you room. All right, so going back to my colors here. All right, so x equals, my a value is 1, my b value is negative 3, and my c value is 9. And if you forgot, you do need to make sure your equation is equal to 0, so it must equal 0 before you start plugging in values into the formula. So my b is negative 3. So if I ask my skill, so negative b means the opposite of b. So if b is negative 3, the opposite of that would be positive 3. Then I'm going to put my plus minus, then square root, and now I'm going to square my b value. And when you square that number, it's always going to be positive. This number should never, ever, ever, ever be negative. So negative 3 squared is a positive 9. Then minus 4 is part of the formula, don't forget that. And then mentally, I'm going to multiply my a times my c. So a is 1, c is 9, 1 times 9 is 9. And then my denominator is 2 times a. Since 1 is a, 2 times 1 is 2. So now I'm going to go back to where I was up here. So just like I was here and I simplified, that's where I'm at right now with this problem. So I'm going to take this radical off to the side, and I'm going to simplify it separately. So I've got 9 minus 9 times 4 is 36. When I subtract 9 minus 36, I'm going to get a negative 27. So again, that negative can be factored out as its own factor of square root of negative 1. And now that we're looking at 27, think of a value or a factor of 27 that's a perfect square. 9 is that factor. Again, if you need to make a list, you've got 1 and 27, 3 and 9. Those are your only factors of 27. 1 cannot help us, but 9 can. So one of my factors is going to be 9, the other is 3. So if you were to multiply this back together, it would equal what you started with, because negative 1 times 9 times 3 does equal negative 27. And that's still a square root. We have not taken any square roots yet. So now we're ready to take a square root. The square root of negative 1 is I. The square root of 9 is 3. The square root of 3 cannot be simplified. So when I put this together, it's 3i square root of 3 or 3 square root of 3i. Either one of these are fine, but that's going to go back now over here. Now don't forget your denominator. You're dividing by 2. So I can put this whole thing over 2, or I could write it as 3/2 plus or minus 3i square root of 3 over 2. So there's different ways of writing your answer as long as you understand that they are equivalent. Yeah, the other way we could also do it is write it is 3/2 plus or minus 3 square root of 3 over 2i. So that's kind of the way it looks in higher level math classes. So any of these will be fine. All right, one more. So use this darky rose one. All right, so once again, we are going to have to use quadratic formula here. I'm going to show you off to the side why we cannot use factoring. But do not write this down because I'm going to erase it in a minute. So if we were going to try to factor this, I would have to use AC method. So I would have to turn the 3 terms into 4. Oops. And then negative 5 will go here. When I multiply my A times my C, I'm going to get negative 15. So I would need to find 2 numbers that multiply together to equal 15, but have a difference, because it's negative, of 6. Well, my factors of 15 are 1 and 15 and 3 and 5. So I know that my signs have to be different. The larger one has to be negative to make it negative in the middle, but negative 15 plus 1 would be negative 14. So if this was a negative 14 in the middle, I could factor it. Negative 5 plus 2 would be, or sorry, negative 5 plus 3 would be negative 2. If this had been a negative 2, then I could factor it. But negative 6 cannot be factored. So we cannot find 2 factors of 15 that have a difference of 6. So I'm going to erase all this down because that's not factorable. So once you realize it cannot be factored, then your only method of solving a quadratic is quadratic formula. Keep in mind also, you could only use quadratic formula when dealing with a quadratic equation. When you have powers that are bigger than 2, do not use quadratic formula. All right, so once again, using my formula here, start out with x equals My A value is 3, my B value is -6, my C value is -5. Since B is -6, the opposite is +6, plus or minus the square root. -6 squared is 36, and then -4. Multiply your A times your C, so 3 times -5 is -15. And that all is divided by 2 times your A, so A is 3 times 2 is 6. So again, I'm doing these little pieces of the quadratic formula in my head to save some space and time. All right, so once again, I want to take this radical off to the side and simplify it separately. So I do have the 36 here. Now the -15 times the -4, this will now give us a positive or a plus 60. That sign, again, is mostly where people make mistakes. So be careful of this sign. So now when I add the 36 and 60, I get a square root of 96. So now we need to find a factor of 96 that is a perfect square. So just for example's sake, I'm going to pretend that you don't always think of the largest perfect square. So I could break this down into square root of 4 and square root of 24, which is fine. However, the square root of 24 can be factored again, or can be broken down again into the square root of 4 and the square root of 6. So make sure if you use a smaller perfect square than there might be a larger perfect square that's a factor of 96. Actually, there is. It's going to be 16. But you don't have to always figure out what the largest one is right away. You can start with 4. 4 is a perfectly good perfect square. It is a factor of 96. That does make this other number smaller and easier to break down again. So now, if you do that, the square root of 4 is 2. The square root of this 4 is also 2. The square root of 6 cannot be reduced. So we get 4 square root of 6. All right, so going back now over here, I have my 6 plus or minus 4 square root of 6. And my denominator is 6. So I'm going to divide both parts by 6 and reduce. So 6 over 6 is 1, plus or minus. The 6 over 4 reduces to 2/3, and then square root of 6. And that is my exact value. We are not doing decimal values quite yet. We will do that when we get closer to graphing. For right now, we're just solving and we want exact values. All right, so again, some of you might see there's different ways of writing this. You could have simplified it. So going back to the 6 plus or minus 4 square root of 6 over 6, at this point, if you reduce the 6, 4, and 6 all by 2, so dividing each of these by 2, you would get 3 plus or minus 2 square root of 6 all over 3. So that's also another common way of writing it. But these are equal. They are the same values. All right. So hopefully that was a good review of solving quadratic equations with quadratic formula. You will be doing that a lot in this class, so try not to get overwhelmed by it, but just keep doing your best, keep trying, because you will become experts at it before you leave this class, if you pass this class. All right, moving on to example F. So now we have some things that have some larger degrees, and this is where we were yesterday when we had solving of polynomials part 1. But what was nice about yesterday's lesson is that everything could pretty much be factored. And starting out here, we are going to have some that could be factored. But we are going to also have things that some that we have to use quadratic formula. This first example, just like yesterday, you have to set the equation equal to 0. So I'm going to take this term basically and subtract it and move it to the other side. Since it's positive on one side, it's going to become negative on the other. So when I rewrite this, I get x to the 6th plus 10x to the 4th minus 24x squared equals 0. So just like yesterday, you want to look for, and all of our factoring, we want to look for greatest common factor. So all three terms have x squared, so we can factor out a x squared from all three terms, making this one left over be x to the 4th plus 10x squared minus 24. Again, keep in mind, if you have three terms there, you should have three terms here. And if we multiplied it back together, it should equal what you started with. All right, now we have a basic trinomial. However, there's an x to the 4th and an x squared. So this can be factored into two binomials. But because it's an x to the 4th and we need an x squared in the middle, these need to be x squared terms right here. So you have x squared here times x squared there to give you the x to the 4th in the middle, or in the first term here. All right, so now we need to find two factors of 24 that subtract, because it's negative, or have a difference of 10. So if you think of your factors of 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6. Because it's a negative 24, your signs have to be different, which is why I try to think of numbers that have a difference of 10. Because the 10 is positive, the larger number has to be positive. So if I look at my pairs here, if the larger number is positive and the smaller number is negative, the only one that's going to give me a sum of positive 10 is the positive 12 and the negative 2. Now, a lot of students see that 10 and they want to automatically put 4 and 6 because they add up to 10. However, your signs must be different in order to multiply together to equal a negative 24. So you have to use 10 and 2, or 12 and, not 10, 12 and 2, not 4 and 6. So the positive 12 times the negative 2 is negative 24. 12 and negative 2 combined will give you a positive 10x squared in the middle. So again, if you were to multiply these binomials back together, it would equal what you started with. All right, so here's where we were kind of at yesterday, but we're going to have a couple of answers that are going to be imaginary. Keep in mind that x squared represents two factors of x, and each factor of x has a solution of 0. So x is going to equal 0 with a multiplicity of 2, and that represents two of your solutions. Because if you look at the beginning, we have a 6 here, which means there should be 6 solutions all together. So 2 of them are going to be 0. So now look at the next factor, the x squared plus 12. I'm going to change colors here to kind of keep it different so you can see where I'm getting these from. So this x squared plus 12, if I take x squared plus 12 and set that equal to 0, this is where we saw problems right here. So these three examples were preparing you for these kind of factors. X squared plus 12 equals 0. Subtract 12. Square root both sides. Don't forget, it's an even root, so you're going to have a positive and a negative root. Now, if I factor this square root of negative 12 into a square root of negative 1, square root of 4, and square root of 3, the square root of negative 1 becomes I, the square root of 4 becomes 2, so I'm going to have 2I. Square root of 3 cannot be simplified. So that there does represent two different solutions, positive 2i squared root of 3 and negative 2i squared root of 3. And then my last factor that I kind of have no room to play with, I'm going to have to move this over here. If I take x squared minus 2 and set that equal to 0, again, you want to get the x squared by itself, so you add 2 to both sides, then square root both sides, and you get, again, two solutions because there's a positive and a negative square root of 2, but the square root of 2 cannot be simplified. The only factor of 2 that's a perfect square is 1, and you cannot simplify radicals using a square root of 1. All right, so now we have all 6 solutions. We've got two solutions of 0, positive 2i squared root of 3, negative 2i squared root of 3, positive square root of 2, and negative square root of 2. That's our 6 solutions altogether. I know you're probably worn out by now. So we got one more to go, one more example, and then you get to practice these on your own. All right, so once again, you have a polynomial function. You have to, first of all, get this equal to 0. So you're going to add 256 to the other side and rewrite this as x to the 4th plus 4x to the 3rd plus 64x. And that now is a positive 256, and you want to set it equal to 0. All right, then next step, look to see if there is a greatest common factor. So they do not all have an x. The 256 does not have an x, and the x to the 4th does not have a coefficient, which means they do not have any common factors in all 4 terms. But since there are 4 terms, we can try to factor it by grouping. So with the grouping, you're going to cut this in half, factor out your x to the 3rd, actually. When you factor out x to the 3rd, you get x plus 4. And then in the second two problems, 64 and 56 seem like some pretty big numbers. But keep in mind, when you're factoring by grouping, whatever you factor out of these two terms has to leave you with the same binomials you had here. So this has to be x plus 4. Well, if this is 64x, what would I have to divide from 64x to get just x? Well, 64. And again, that sign needs to be brought down. Don't forget that sign. So plus 64. So you're factoring out a 64 from both of these terms. And when you divide 256 by 64, you also get 4. All right, so going back to the whole factoring by grouping concept. So think of this as one term, think of this as another term. What do they have in common now? The x plus 4. So I'm going to factor out the x plus 4, and then the x to the 3rd plus 64 goes in the other set of parentheses. All right, so now we're almost getting there. The x plus 4 is a linear factor because x is to the 1st power. So we're done factoring that one. If I set that factor of x plus 4 equal to 0, subtract 4, I get a solution of negative 4. So that's one of my solutions, but I need to have 4 solutions altogether. So that means I need 3 solutions from here. Now, some of you might just look at that and be like, oh, can't I just make that x plus 4, x plus 4, x plus 4? No, 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 no. This is something that we learned in lesson 2.2, I believe it was. You have a perfect cube. X to the 3rd is a perfect cube. 64 is a perfect cube. This is a sum of cubes. And when you factor a sum of cubes, which you will have to do very often, it factors into a binomial and a trinomial. The cubed root of x to the 3rd is x. The cubed root of 64 is 4. Then you take your x and square it and put it here. Then you take the 4 and the x and you multiply them together and you get 4x. Then you take your 4 and square it and put it here. And then you look at your signs. The first sign is the same. So remember the acronym SOAP, same, opposite, always positive. So same as the original. This next sign is going to be opposite. So if this is plus, this is minus, and this sign is always positive. So if you don't remember how to factor that sum and difference of cubes, you need to go back to lesson 2.2 and work on those again. Now that we have factored that sum of cubes, we can then get our other solutions. So we have another factor now of x plus 4. So that factor of x plus 4, again, is going to have a solution of negative 4, which means we have negative x equals negative 4 with a multiplicity of 2. Because there are two solutions of negative 4, there are two factors of x plus 4. However, this trinomial here cannot be factored, which means we are going to have to solve it with quadratic formula. And since I am running out of room, it looks like I'm going to have to go into some of this room from problem 2. All right, so I'm going to use a different color. Blue. All right, so I'm going to solve this factor with quadratic formula. So I'm going to start that here. X equals b is negative 4, so the opposite would be positive 4, or just 4, plus or minus the square root of b, again, is negative 4. If I square it, I get 16 minus 4. And then in the parentheses, I'm going to multiply my a value, which is 1, times my c value, which is 16. 1 times 16 is 16. And that all gets divided by 2a. A is 1 times 2 is 2. So now we want to simplify that radical. So I'm going to actually use this little bit of space up here. So the 16 times the 4 is going to give me a negative, what is that? Negative 64. Yeah. 4 times 4 times 4 is 64. All right, so 16 minus 64, which then will give me a square root of negative 48. The largest perfect square that's a factor of 48 is 16, so I'm going to factor that into square root of negative 1, square root of 16, and square root of 3. So when I take the square root of negative 1, I'm going to get I. So this now, come back down here, 4i square root of 3. So I'm going to have x equals 4 plus or minus 4i square root of 3, and I'm going to divide both parts by 2 and reduce. So 4 divided by 2 is 2. You can only reduce whole numbers with whole numbers. So this 4 divided by 2 is also 2. This is an imaginary number, so this is something that cannot be combined or added together any further. You cannot add the 2 with the 2i squared root of 2 because 2 is a rational number and 2i squared root of 3 is not only imaginary or complex, it's also irrational. So anyway, that is your solution, your other two solutions for example G. So you have two solutions that are two values of x that are negative 4, and then you've got 2 plus 2i squared root of 3 and 2 minus 2i squared root of 3. And that concludes our lesson for today. Thank you very much for listening. Good luck on your homework.